Hey everyone, it's Mike here from ArnoldTutoring.com, and today we are going to talk about end behavior of graphs or functions and sort of what end behavior means when we're talking about what these functions look like on a graph, as well as how to determine, just by looking at an equation, what the end behavior of that function will be. So first of all, what is end behavior? Well, I think of it as what is happening to y when x gets really big or really small. In other words, as x goes towards infinity, positive infinity, and as x goes towards negative infinity, is the function getting really big or really small? Now this always happens with polynomials. So in other words, look at the four functions that I've got here. You can see they're all polynomials in that there's no fractions. They're not rational functions. They're not exponential functions with variables in the exponents. They're just polynomials, right? X's with exponents on them. So what that means is that as x gets really big, y is either going to get really big positive or really big negative. So if we think about our x and y axes here, let's take a look at this first function. So we have y equals 3x squared. Well, as I put a really big positive x value in there, in other words, as I'm coming out towards the right here, really big positive x, what's happening to y? Well, we're squaring that x value, which means it's going to be positive, and a really big number squared becomes an even bigger number. So that means as we get out far to the right here, our function's getting higher and higher because the y value is going up as the x value is going up. Let's think about it on the negative side. So when we're out to the left here and x is getting really big negative, what happens to y? Well, that really big negative number is still being squared here, which is going to make it really big positive, right? A negative number squared becomes positive, really big. So as we move to the left here, we're still getting really tall with the function. So obviously this is a very basic sketch, but we can see with this red function, our end behaviors, basically the function's going from quadrant 2 to quadrant 1 as we read left to right. Okay, so again, this is quadrant 2 over here, this is quadrant 1 over here, we've got 3 down here, and 4 down here for your reference. So the end behavior of this y equals 3x squared is from quadrant 2 to quadrant 1. Now, how did I know that? Well, again, we sort of walked through it because the exponent is 2 there. Let's take a look at the blue one. Here we have a couple different x's. One exponent is 4 and one exponent is 3. Now remember that end behavior only really matters when x is getting really big positive or really big negative. So once you get out to those really big numbers, the highest exponent in the function, that's the term that's really going to win. So in this case here for this second one, this negative x to the 4, that's the only term we care about. You only care about the highest exponent in the polynomial when we're talking about end behavior. So we can think about this. It's very similar to x squared because it's an even exponent. Even exponents make very big positive numbers positive. They make very big negative numbers positive as well. So it would initially look similar to the end behavior of the red function, except for this negative sign in front. What does that do? Well, we know a negative sign in front flips a graph. So the end behavior here is going to be opposite from the end behavior of the red graph, and it's going to be, I don't know exactly where it's going, but we don't really care what's happening in the middle. We only care about the end behavior. So it's going to go from 3 to 4. Okay, so again, the even exponent was the tip-off that I'm going to start thinking it's going from 2 to 1, but then that negative sign in front is going to flip it on the x-axis, so its end behavior will be from quadrant 3 to quadrant 4. Now let's look at the green function. Once again, with the green function, we have multiple terms, but this 2x cubed is the largest term, the highest exponent, so that's the only one we're going to focus on. Now this one has a negative exponent, so it treats numbers a little bit differently. When x values get really big positive, when you cube that big positive number, that's still really positive. So we're somewhere up here in quadrant 1, right? As we go really big x, y gets really big as well. But when we go very negative x, a really big negative number cubed becomes a negative number, not a positive number. So that's going to end up in quadrant 3. In other words, as x gets really big negative, so we're coming out to the left, y gets really big negative because we're cubing that x value, which is why it's going down, negative y. Okay, exact same thing for the last function. Again, we can see it's an odd exponent. So that's an 11. So we're going to start it by assuming that it looks just like the green one, which also had an odd exponent in the tallest term. But once again, we've got that negative sign in front. So it's going to flip the green one on the x-axis. So it's going to start from quadrant 2 and go down to quadrant 4. Again, these are just absolute predictions is what's happening in the middle. We don't really care in this exercise. All we care is the end behavior. So as x gets really big, what's happening to y? As x gets really big negative, what's happening to y? Two things then to recap that you need to look at. One is the exponent on largest term. And 2 is look for a negative sign. So just based on the exponent with the largest term, I'll write it up here. If it's odd, it's moving from quadrant 3, that's a 3, to 1. If it's even, so if that largest exponent is even, just like the red function, it's moving from 2 to 1. Again, this is as we read left to right. And then a negative sign flips in the x-axis. If we can remember these rules right here, we'll at least know the end behavior of functions, so that can help us graph when we're just given an equation like this, a polynomial equation, we can have an idea as to what it's going to look like. Hopefully this is helpful. Again, end behavior, as x gets big, what's happening to y? As x gets really big negative, what's happening to y? You can always email us more questions, info@arnoldtutoring.com. Hope you found this helpful, and good luck graphing your next polynomial.